Welcome viewers. In this video we will see the hexadecimal to binary, hexadecimal number system to binary number system. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic hexadecimal, base 16 to base 2, right? 16 to 2. This conversion is coming under grouping technique. Grouping technique means if the octal number is there, we need to change it into 3 digits. The binary is combined into 3 digits. Hexadecimal means combined into 4 digits. Each and every number is represented by 4 digits. Octal means 3 digits. So accordingly, based on that, we can convert this hexadecimal to binary number. So the first we go to the example 1. First number given is 2D5. Base 16. So given hexadecimal number is 2D5, right? So first what we need to do, first write these 2D5 separately, 2 separately, D separately, 5 separately, right? Now convert this hexadecimal number into binary number and make it as 4 digits. We need to make it into 4 digits, right? What is the D value in hexadecimal? Up to 0 to 9 as it is. From 10 onwards it is written in a alphanumeric value. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F, right? From 0 to 9 as it is. From 10 onwards we need to write in a alpha value, alphanumeric value. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. So this D is written as 13, D is 13 and 5 written as it is, right? So the given hexadecimal number is written each and every digit separately. The D is converted in D is written in equivalent value 13. Now we need to convert these 2 into binary number separately. 13 into binary number separately. 5 into binary number separately. And important thing, make it as 4 digits. If the digits are lesser, we need to add 0. That is very important. First we will take this number 2. We will convert this 2 into binary. 2. 2 divided by 2 means it goes one time, balance is 0. So the value is right in a reverse order, 1 0. This digit is sorted, so we write 0 0. This is MSV, is not a mostly a problem, but anyway we can add 0 0. Right? The 2 is converted into binary, the equivalent is 1 0, added 2 more 0, make it as 4 digits. Then convert this 13 into binary. 13 divided by 2. 13 means it goes 6 times, balance is 1. 6 is divided by 2. It goes 3 times, balance is 0. 3 is divided by 2. It goes 1 time, balance is 1. Right? So write in the reverse order, 1 1 0 1, 1 1 0 1. Right? The 13, while converting 13 into binary, what we got? 1 1 0 1. Write in a reverse order, right? Write in this order, 1 1 0 1. So it is already in a 4 digits. Now convert the 5 into binary, 5. 5 divided by 2, it goes 2 times, balance is 1. 2 divided by 2, it goes 1 time, balance is 0. So it is 1 0 1, right, in a reverse order, 1 0 1. It is very important to add 0 here. The 0 is not added, the value will change, right? So here 1 0 1 only 3 digits are available, add 0 here. So 0 1 0 1 is the value, right? If the 0 is not added while combining all the digits, the value will change. It is important to add the 0 here, right? Now 2 is converted into binary, D is converted into binary, 5 is converted into binary. Here 1 0 is added because of shortage. Now combine all this value. These two zeros not here affect because it's connected as added in the MSB side. It will not affect much more, but this 0 will affect much. So you must add 0 here. Now combine all this value, 0 0 1 0, 1 1 0 1, 0 1 0 1. So this is nothing but a binary equivalent of this hexadecimal number 2D5. Right? How we are doing? 2D5 is written separately. The D is written in numerical value. 2 13 5 is converted into binary separately and make it as 4 digits, and all digits are combined together. That is nothing but your final answer. Right? Now we'll go to the second example. Next example, BE2A. The given hexadecimal number is BE2A. That should be converted into binary number. First, what we need to do, write the digits separately. B separately, E separately, 2 separately, and A separately. Right? What is the B value? B is nothing but, see here, B is nothing but 11. So B is nothing but 11. What is E value? E is nothing but 14. Then 2. What is A value is 10. Right? Now this alpha numeric value is converted into numeric values. B is 11, E is 14, 2 as it is, A is 10. Next, what we need to do? We need to convert this each and every digit into binary value, right, and make it as 4 digits. We need to make it as binary value and 4 digits. First, we will convert this 11 into binary. 11 divided by 2, 5 times it goes, balance 1. 5 divided by 2 goes 2 times, balance 1. 2 divided by 2 goes 1 time, balance 0. So normal binary to decimal to binary conversion. Right in this order, 1011, 1011. Right. So B is 11 equivalent to binary is 1011. Now we'll take E. E is 14. 14 divided by 2 is 7. Balance is 0. 7 divided by 2, it goes 3 times, balance 1. Right? 3 divided by 2, 1 time, balance 1. So 1110. Right? 1110. So already 4 digits are available. So no problem. 4 digits are available. Right? Then convert this 2 into binary. 2 divided by 2 means 1 time, balance 0. So write in this order 1 0. But it is essential to add 2 zeros here. Right? Otherwise the value will change. Right? While combining these digits, if they are not added 0, the value will change. Right? So here only 2 digits 1 0 available. We need to make it in 4 digits. Right? 2 more zeros. So it is 0 0 1 0. Right? Finally we are going to combine this value. If the 0 0 not written, they will combining this equivalent value is not correct, the value will change. Right? So it is necessary to add 0 0 while writing. Only we have 1 0, so it is written 0 0. Now convert this A. A is nothing but 10. 10 into binary. Right? 10 divided by 2 goes 5 times, balance 0. 5 divided by 2, 2 times, balance 1. 2 divided by 2, 1 time, balance 0. So 1010 is the binary equivalent of this number, decimal number 10. 1010. Right? Now B is converted into binary, E is converted into binary, 2 is converted into binary, 4 is converted into binary, and make it as 4 digits. These 3 are already in 4 digit, but 2 is having only 2 digits. We added another 2 zeros. The 2 zeros not added, the value will change. It is necessary to add 2 zeros. Now combine all these values. 1011, 1110, 0010, 1010. So this is nothing but binary equivalent of this hexadecimal number BE2A. Right? So in this video we discussed 2 examples for converting hexadecimal to binary. Other conversion system also available, separate videos available. Their details are given in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.